In these examples, we're asked to find indefinite integrals, and we're going to focus on using these three rules. In this example, it doesn't really look like any of the rules we have here, so we try to simplify first. Hopefully we see that we can multiply in here the x to the power of a half. So root x, or x to the half, multiplied by x squared, gives x to the power of, this is 4 over 2, this is 1 over 2, so 5 over 2, minus x to the 3 over 2. Keeping that in brackets so that the dx can be distributed. Now we can treat each term separately. We don't have any constants to worry about, so we can integrate. This becomes x to the 7 over 2 over 7 over 2 when we add 1 and add 1. Now notice what's going to happen here. The 2 comes up and the 7 will stay on bottom. So when we're dealing with fractional exponents, sometimes it's actually faster to just do that all together. So this one is x to the 5 over 2 when we add 1. It's over 5 over 2, or times 2 over 5, because the reciprocal of this is what we end up with. So with enough practice, hopefully you can do that all together. Since we didn't do it here, we have to simplify. So that's x to the 2x to the 7 over 2 over 7 minus 2x to the 5 over 2 over 5 plus a constant. In this example, when we have the square root, we want to write it as an exponent. So once we do that and we bring this up, we get something that looks like rule 1 and rule 3. So x to the 1/2, sorry, r to the 1/2 minus r to the minus 3 dr. And now, treating each piece separately, as we can do, we integrate using rule 1. So this becomes r to the 3 over 2 over 3 over 2, or well, why don't we just write that? 3 over 2 over 3 over 2. What I was saying was, or we can simply write 2r to the 3 over 2 over 3 minus r minus 3 plus 1 is minus 2 over minus 2 plus a constant, and simplifying we end up with 2r to the 3 over 2 over 3 plus, the minus minus goes together, 1 over 2r squared plus a constant when we bring the r down. In this example, we have division. We have nothing here that lets us treat division, so we need to simplify. With all integrals, if it doesn't look like something that you have rules to solve, simplify it first. Use some algebra. Make it look different. So here we can write it as the integral of 1 over 3x dx minus the integral of root x over 3x dx. So that's just basic algebra. This can go with both pieces, and this third rule which says we can separate the terms. Removing the constant now and writing the exponents as negatives, we end up with 1 over 3 x to the minus 1 minus 1 over 3 integral of x to the minus half dx. X to the half minus 1 is x to the minus half. 1 over 3 came out. Now, the constant stays. When you go to integrate this, you would end up with x to the 0 over 0, which is not allowed because this rule is not valid for n equal to minus 1. That's because the integral of x to the minus 1 is the natural log of x. or the absolute value of x to be exact. That hasn't been covered in class yet, so for now we'll just treat that as a given, that the integral of x to the minus 1 of dx is equal to the natural log of x plus a constant. Don't worry too much about that. We will cover it in class, but to do this example was necessary. This one you should be able to do. That's 1 over 3 stays. This here is x to the 1/2, negative half plus 1 is 1 over 2, over 1 over 2 plus c. And simplifying gives us the natural log of x over 3 minus 2x to the half over 3 plus a constant.